Okay, so very good morning to all the dear students. Today our topic of lecture is algebraic expressions and identities. This is a very essential topic you have to learn because in the long run of algebra for your mathematics syllabus for up to class 10, you will be requiring all these concepts along with this formula to do the higher order numericals in this chapter. So let us start with algebraic expressions and identities. So first, why we need to know the algebraic expressions and what they actually mean. Basically, if someone asks you to bring 3 kg of maida from the shop, you will be bringing 3 kg of maida from the shop. Or suppose someone asks you about the cost of your pen, you will be answering with rupees 10 or rupees 20, which is exact. So when the value is known, then we put a number in our answer. That means if you are dealing with different numbers, if you are answering with numbers which has the definite value, definite answer, then you are requiring the number theory, number system. There you will be answering in terms of your numbers. But what happens is if someone asks you that there are 40 students in your class, so can you tell me what is the height of your classmates? Are you? So now you cannot put a definite number against of your question. So what can you do? Now you can assume that, let us assume that the value of height of each student in my class is X. Now this X can vary from 5.1 to 5.55 feet, etc. That means when you are not known or you don't have a sufficient data about the number, what it should be, then you will be taking the help of algebra, the vowels, the A to Z, you can assume anything and you will be answering in terms of algebraic expressions, where again you will be telling this algebra as numbers, but which can take different values in different situations depending upon the question and on which you are measuring. So again you can perform summation, subtraction, multiplication, division, everything, and do simplifications. So for doing this kind of numericals, we will be requiring some formulas, and let us now know how these formulas are coming and what is the significance behind using these algebraic expressions. So okay, now algebraic expressions are the equations we get when operations such as addition, subtraction, multiplication, division, etc. are operated upon by any variable. This term is very important, variable. I have told you that when you are not provided with a definite answer, then you will be requiring these algebraic terms. Now, when you are saying that the age of a student in my class is X, probably it may be 14 years or 13 years, you do not have a particular value. Now, this X is a variable which can take any value. Therefore, this is called the algebraic expression or a variable expression, because this expression where addition, subtraction, multiplication, divisions all are done upon some variable quantity. So what is variable? Variable is something which can vary, which do not have a particular definite value. So a variable expression is a combination of terms by the operations such as addition, subtraction, multiplication, division, etc. For example, let us have a look at the expression 5x plus 7. Thus we can say that this 5x plus 7 is an example of algebraic expression, because here 5 and 7 are numbers, but along with that it is there is x, which is a variable. If you put x equal to 1, what will be your answer? It will be 12. If you put x equal to 2, what will be your answer? It will be 17. That means depending upon the value of x, this expression 5x plus 7 is having different values on different situations. So this is a variable expression where we have an unknown variable, which is x, which can have any value depending upon the situation. There are different components of an algebraic expression. So now when I'm saying this is 5x plus 7, then how you can identify these different terms here? What is the significance of x here? What is called 5x and what is called 5x plus 7 whole? So if I take this example 5x plus 7, as you can see here, there's this coefficient. This is 5. That means the numerical value, which is in multiplication with the variable term, is called the coefficient. If I tell you it is 5x cubed, then what will be the coefficient, as the variable here is x and it is of the order of 3, that is x to the power 3. So whatever you put at the power here, x to the power nothing means x to the power 1. So it's having an order of 1. If I put here 2, it will be of 2x square. If I put it 3, it will be x cubed. So that is called the order of the variable. But whatever is before the variable, that is whatever numerical value or number is in multiplication with the variable, is called the coefficient. So 5 is here the coefficient, and 7, which is having no variable in the along with that, is called the constant. So all these terms together, that is coefficient, variable and constant, is making your variable expression or algebraic expression. Fine. So now I have given a short example here. Now I have told you that x, let us solve the algebraic expression x cubed plus 3x square minus 2x cubed plus 2x minus x square plus 3 minus x. Here what you have to identify, that is, here the variable is x. We have the variable x because the only unknown term here is x. We do not have any other y or z in this expression. But along with that, we have different terms here. We have 1, 2, 3, 4, 5, 6, 7 terms here. Later we will know that this is called a polynomial. Now what is this? I have told you that whatever is in the power of x of the variable is called the order. So here, if I put x to the power 3, the order is 3. That means x cubed. This is cubic expression. Here it is x square. That is the x to the power 2. X cubed, x to the power 1. And this is again x square and 3 minus x. So here, what will be my first step to solve this algebraic expression? First, I will see which are the like terms. Later, I have mentioned what are like terms. First, now I'm just giving you a simpler form. That is, the terms which are having the same variable along with the same order. That means if this x cube, this minus 2x cube are the similar terms here, they are called the like terms. So I have put a bracket, I have put them within a bracket. Next, 3x square minus x square are also having the same term, and they are also the like terms, so I have put them in a bracket. Again, 2x minus x is same. They are also like terms, so I have put them in a bracket, and the only constant in this expression is 3, so I have put it separately along with the positive sign. Now operating the normal algebra here, x cube minus 2x cube will give you the minus x cube, because 1 minus 2, that is the coefficient, 1 minus 2 will give you minus 1. Here 3 minus 1 will give you 2, so this is plus 2x square, and this is 2 minus 1, that is only 1, that is x. So your final answer is minus x cube plus 2x square plus x plus 3. So first, what are the steps to simplify or solve an algebraic expression? First, you identify what is the variable here and how many variables are involved in the expression. Later, you will know that how you will classify them. I have just given in the downward drop-down box here. So first step, you identify the variable and the number of terms there. Then you identify which are the like terms. That is the terms having the same variable along with the same order. Then you put them in a bracket and do the algebra among them. That measures the summation or subtraction, whatever operation you have in the expression. Then you put the constant apart from that and just put them along with the variables itself will give you the simplified algebraic expression. So, okay. Now, further moving into the detailed analysis, that is types of algebraic expressions. Now, if you are provided with an algebraic expressions, there are different ways in which you can classify them. First, I have given you that the 3 main types of algebraic expressions are possible. The 3 main ways in which you can classify the algebraic expressions basically. The first is based on the number of terms they contain. That means if your polynomial contains 2 terms, it will be called binomial. If it is containing 3 terms, it will be called trinomial. What are called terms? Because here you have 1, 2, 3, 4, 5, 6, 7. If you simplify them, you have 1, 2, 3, 4. So number of terms you are having in the expression is going to determine the name of the polynomial, name of the algebraic expression. Next is based on the highest degree of the terms, that is, here you have x cube, x square, x, and x to the power 0, that is the constant. So highest order is 3. So based upon the degree, highest degree of the terms, again you can classify them based on the number of variables it contains. If it here you are having only one variable. If suppose you have 2 or 3 other variables, you will be naming it in a different way, right? So 3 different ways are there. Something the first one is that is based on the number of terms it is containing. Second one is the highest degree of terms it is containing, and the third one the number of variables it is having. Okay, so next is algebraic expressions based on the number of terms. The first way that is based on the number of terms they contain. First, it is monomial. That is the algebraic expression which contains only one term. So if you have 5x, 2xy, minus 3x square b or minus 7, here you can find that I have put a comma after each and every term. So you are having only one term. Look, here you have 2 variables, but we are not much concerned about how many variables are there. We are concerned about that how many terms are there. So you can see that there are 4 terms as, see 1 terms in each expression. So these terms or these expressions, these algebraic expressions will be called the monomials. If you have 2 terms, as we had the previous example, that is 5x plus 7, that was a monomial because there also you have 2 terms in the expression. If you have 3 terms, that is a plus 2b plus 5c, trinomial, quadrinomial, 4 terms, and like this. An expression containing 2 or more terms is known as a polynomial. That means the trinomial, quadrinomial, all these are being incorporated within the polynomial. So it includes binomial, trinomials, quadrinomials, and all the algebraic expressions with 5 or more terms. Whatever be the number of terms in the expressions, you can call it polynomial if the number of terms is greater than 1. Right? So this is the first way in which you can classify or name the algebraic expressions. Okay. Next is algebraic expressions based on algebraic expression based on the highest degree of terms. The first degree, if you have in your expression the highest degree of the variable as 1, then you will be called it first order or first degree equation. Next, if you having this x square plus 3xy plus 12y square plus 3x minus 8, here you can see that the highest order of x is 2, highest order of y is 2. Here also x into y, that means it will be kind of 2 order 2 or degree 2. So the highest order of the variable here is 2. That's why it's called second degree polynomial, or second, yeah, you can call it polynomial because we have more than one term here. Third degree, if you are having the highest order of x as cube, though there is no no y cube present here, but any one of the variable having the highest order is called depending upon the order of the variable or the degree of the, not order, you should not tell it order, it should be called degree. The highest degree of the variable should be considered to name the polynomial. So it is called the third degree polynomial here. The third way, that is the algebraic expressions based on number of variables it contains. If it contains only one variable, you are just provided with y minus 9. Here your only variable is y. It is called one variable polynomial. If you are having 2 variables, suppose you are having x square plus xy plus 2y square. So here you are involved with, your expression involves 2 variables x and y. 2 are unknown. So you will be called it 2 variables polynomial. If you are having 3 variables x, y, z, x cube plus y cube plus z cube. This is an example of third 3 variables polynomial which is having the degree of 3. So these 3 ways are clear. That is, you can classify an algebraic expressions depending upon the highest order of terms, the number of variables it contains, and the number of terms it is having. So if it has more than one terms, it is called polynomial. The highest degree of the variable will determine the degree of the polynomial, and the number of terms will be saying whether it is 1 variable, 2 variable, or 3 variable polynomial. So, and as I have mentioned you, the like terms and unlike terms, the like terms and the terms having the same algebraic factors known as like terms, and which are having different algebraic factors are known as unlike terms. In this expression, if you are asked that 2xy minus 3x plus 5xy minus 4, the term 2xy and 5xy are the like terms because they are having the same algebraic factor, that is xy. But the terms 2xy and minus 3x are not like terms because they are not having the same algebraic factor, factors. One is having 2xy, whereas another one is having minus 3x. In one expression it is only x, and in another expression it is x into y. So they are called the unlike terms. So up to this, we have learned about the degree of the polynomial, the name of the polynomial depending upon the number of variables it is containing, and then we have learned about like and unlike terms. And as I have mentioned earlier, that the first step doing the simplification of an algebraic expression is identify the variable and number of variables, and then you have to put the like terms in a single bracket and do the algebraic operations on them, and you can hence simplify the algebraic expression into a simpler form. So now, in the first question, you are asked to add 5x squared minus 7x plus 3. You can say this is a polynomial, and the highest degree of the x is 2. This is second degree polynomial, right? And it is containing 3 terms. Okay, nextly it is minus 8x squared plus 2x minus 7, and third one is 7x squared minus x minus 2. You can see in the 3 expressions, x is having the highest degree 2. So they all are second degree trinomial basically, because they are containing 3 terms, and it is single variable polynomial, as we were only given with x terms here. So when you are adding them, you are getting this long chain, where the first thing is to identify or the collecting the like terms within a bracket. So for doing that, here the like terms are 5x squared, minus 8x squared, and 7x squared. We put them in a bracket if you wish to do that. Then you put minus 7x plus 2x and minus x in another bracket, because they are also the same. They are also carrying the same algebraic factor. That means they are also like term. And apart from that, you just put the constant terms in the same sequence, plus 3, minus 5, minus 2. So finally, doing the algebraic operations among them, you get 5 minus 8 plus 7 as a coefficient of x squared, minus 7 plus 2 minus 1 as a coefficient of x, and 3 minus 5 minus 2 as the constant term. So doing this, you will be getting 4x squared minus 6x minus 4. In the next expression, you have to subtract 2x squared minus 5x plus 7 from 3x squared plus 4x minus 6. So you will be writing it in this way. Now this minus will be minus 2x squared, minus into minus will be a plus 5x, and minus into plus again minus, so this is minus 7. Again I am repeating, this minus is operating on this polynomial, so the sign is going to be changing. That means in the first expression, minus into plus is something, minus 2x squared, minus minus will give you plus 5x, and later minus 5 plus is minus. So the multiplication rule is plus into plus give you plus, minus into minus gives you minus, but plus into minus or minus into plus is going to give you minus itself. Now later we will be collecting the like term, that is 3x squared to minus 2x squared in one bracket. After that you will be doing 4x minus plus 5x in another bracket, and then minus 6 minus 7. So finally you will be getting the answer x squared plus 9x minus 13. Now again we are asked to multiply minus 8ab square c. This is a single term, so this is my monomial, this is another monomial 3a square b, and later you are given a constant. So now multiply all these things. What you will be doing, that is you will multiply the coefficients itself along the constant term. Next you multiply the variables here, a into a square. The powers are going to be added in the power. That means you will be getting a to the power 1 plus 2, similarly b to the power 2 plus 1, and c will be itself. So you will be getting what? 4a cube b cube c. What I have told you, when you are multiplying two variables of different degrees, suppose x to the power 5 into x to the power 7, what it will be to put x equal to, in the power you put the sum of the two individual degrees, that is 5 plus 7. X to the power 5 into x to the power 7 is going to give you x to the power 5 plus 7, that is 12. Suppose you have x to the power 2 and x to the power minus 2, you have to multiply them. Then what will be your result? Just add the degrees in the power, that is x to the power 2 minus 2, you will be getting x to the power 0, that is simply 1. So these are the rules or tricks you will be learning more when you will be doing much more problems. Now coming to the different formulas you will be requiring for doing different numericals. As you have to learn all this, I will give you the explanation how these formulas are coming step by step. But first, let us learn the Pascal's triangle, which is very, very important, because in later days when you will be in class 11 or 12, you will be learning binomial theorem, where we will be requiring long-term formulas. And for remembering that, you will be requiring Pascal's triangle, because it is the main pillar from which all these types of formulas are going to be formed. Now, how you are going to understand this Pascal's triangle? Just put this 1, then 1, 1, then 1, 1, 1, 1, 1, 1, 1. Don't write this middle terms here. Just make a triangular, a pyramid shape with all this 1. Now, when there is only 1, that means you are having a single term. X, Y, Z, A, B, C, D, or A plus B, B plus C, D plus A, whatever is within a bracket to the power 0, that means you will be given as 1, or the coefficient will be always 1. But when there is 2 terms, 2, 1, then what will happen? Then there will be, if you are having 2, 1, then you will be getting the middle coefficient as 2, because 1 plus 1 is going to give you 2. That means if you are going to write x plus y whole square, when this is whole square, then the coefficient of x square will be this 1. The coefficient of xy will be this middle one, that is 2, which is sum of this 1 and 1. And later you will be getting a y square. If I treat this minus y as plus y, then just there will be a minus sign in the coefficient of xy, nothing else. Similar way, if I go for x plus y whole cube, that is, we are going to put order degree 3. Then what will happen? You put 1 and 1 at the extreme points. Then there will be 2 terms in the middle. And how will this coefficient come? This 2, 1 plus 2 will be 3. Again, 2 plus 1 will be 3. So adding this 2, again, adding this 2 will give you the coefficients of the terms. So x plus y whole cube will be x cube plus y cube plus 3xy. X square y plus 3xy square. I have simplified it and then written, I have written it as x cube plus y cube plus 3xy into x plus y, right? Similarly, if you are asked to do 1 x plus y whole to the power 4, then the first term will be having a coefficient of 1 and the last term will be having again a coefficient of 1. Last term means the higher degree term, and in the middle you will be getting the first coefficient, I mean the first second coefficient as 4, third coefficient will be 6, fourth one will be 4. And how you are getting this? Add this 1 and 3, this is 4, add this 3 and 3, this is 6, and add this 3 and 1, this is 4. This is, I mean, you do not require to know all the degrees polynomial here, because later in higher classes you will be learning how to write the different higher order polynomials in a simpler form or in the definite formula. But just to visualize you that how these formulas are going to be formed and how you should recall them, I have given you this Pascal's triangle, which is, I think, a very a very good and also very tricky way to remember the formulas. So here I have given you x plus y square, x minus y square, the third one, that is x square minus y square, x plus a into x plus b, x plus y plus z whole square. 3 variables are here. X plus y whole cube, x minus y whole cube, x cube plus y cube plus x cube minus 3x, y, z. And these all formulas are going to be very much essential and very much important in doing the numerical problems in later. Before jumping into the numerical problems, where you will be playing with all these formulas, let us just visualize one example from this, that is x square minus y square, how this is coming x minus y and x plus y. So, okay, if I want to know that how this is a square minus b square is going to be a minus b and into a plus b, let us take the help from geometry. As we know that the square is having all the lengths same. So this AC, CD, BC and BD and AB all are having the same length, that is A. Suppose I cut this DE, DF as B, and this is again a square which is having all the sides equal to B. That means this square is having the area of B square, whereas this square ABCD or ABDC is having the area of A square. Now if I wish to calculate the area of this portion, which is the pink portion, what will be my answer? So I will just take the entire area, which is a square, and subtract this small shaded region b square from this. Then we will be getting the pink area. So the left hand side is the area of this pink side. Now again, if I wish to calculate the area of the pink side by fitting only this rectangle AEFP, and also suppose I consider this is ECMN, then I will be taking the area of this rectangle plus this rectangle, which will be given as, because this side is something that is A minus B and this is A. So you will be given as A into A minus B as the area of this rectangle. Again, I am repeating, BF is A minus B and this is A. So the area of this AEFB will be A into A minus B. Whereas this is, in this portion, EC is B, but this CM, suppose I assume this point to be M, then CM is nothing but A minus B. So again, you will be getting what? B into A minus B. So adding them together, A into A minus B plus B into A minus B is going to be A plus B into A minus B. So visualizing the algebraic identity as a geometrical visualization, you can prove that A square minus B square is something A minus B into A plus B. So this is the visualization of this formula using geometry. Now let us jump into some numerical problems. First, in the question you were asked to identify the like terms. So here it is very easy. Z square minus 3z square are like terms. So they are put up within a green circle, whereas 5z and z are like terms. So they are put in a blue circle. In the second numerical, you are given with AB plus BC plus CA equal to 10, S square plus B square plus C square equal to 44, and you are asked to find A cube plus B cube plus C cube minus 3ABC. Okay, so as you know that A plus B plus C whole square is something A square plus B square plus C square plus 2 into AB plus BC plus CA. From that, you can find A plus B plus C whole square. Taking the root of the 64, you will be getting the A plus B plus C, and later A cube plus B cube plus C cube minus 3ABC can be written as A plus B plus C into A square plus B square plus C square minus AB plus BC plus CA, as I have mentioned in the formula sheet, this one. So from this, what you just put the value of A plus B plus C you have got earlier, and then you put A square plus B square plus C square here, which is given, and later AB plus BC plus C, which is also provided in the question, and finally you will be getting this answer. So just you have to apply the formula in different ways to simplify and getting your answer. Next, you are asked to factorize. Now this is factorization. When you are asked to factorize, if this first term, which is containing a quadratic term, I mean a degree 2 term, it's having no coefficient, then what you will do? You will be consider only the constant term and take the LCM, and from the LCM try to make this middle term as sum or subtraction of the LCM factors. Or if you're provided with this constant coefficient before this degree 2 term, then you take this product of the coefficient with the constant term, that is 3 into 10, and then you take their LCM, and from that you try to somehow make 17 by adding or subtracting all these LCM values, LCM factors. So doing in this way, I have done 3 into 10 is 30. Now taking their LCM, I have found that 15 plus 2 is giving me 17. So I have broken this term in this way. Next, I will be taking the common part, that is 3x plus 2. I will be left with x plus 2 plus 5, and in the next term we will be getting 2 as common, and we will be left with x plus 2 plus 5, that is x plus 7. From these two terms you are getting the common term as x plus 7, and you will be left with 3x plus 8. So this is the factorization of this expression. The next formula, I have just simplified them using the identities I have used, and the last one is very essential, but I have used the A square minus B square formula in 2 steps. Again, here in the next steps, I have broken x to the power 4 minus 1 by x to the power 4 as x square plus 1 by x square into x square minus 1 by x square. That means here x square is my A and 1 by x square is my B. So this is A plus B into A minus B. Again, taking this last term, you can factorize it as x x plus 1 by x into x minus 1 by x. That means this is a successive use of or successive progression with the use of a square minus b square formula, where in the first step you are treating this x to the power 4 as a, 1 by x to the power 4 as b. In the next step, x square is your a, 1 by x square is your b, and then last step, x is your a and 1 by x is your b. Yeah, this is very brief and a very fast explanation. You need to do much more examples to get familiar with the types of sums you will be facing, because these types of numericals do really, they require some great practice. So later we'll be discussing all these types of problem along with that, and we will see that how these formulas are getting involved in different numericals depending upon the different situations. So okay, finally, this is a thank you. So we end our class here. Thank you.